Hello everyone and welcome to the EVN Disrupt podcast. My name is Nejdet Zaturyan. I'm the editor of the creative tech section here at EVN Report. My guest today was Gevorg Soghomonyan, the founder and CEO of AimStack. Gevorg shared with us the product they're building, his thoughts on the MLOps space, and we also spoke about what it means to build an open source company. Thank you for listening. Gevorg-chan, thank you so much for being here today.
Cheers. Happy to be here.
Yeah, you're one of the first guys I interacted with even before moving to Armenia in the sort of Yerevan ecosystem. So I think that was like 4 or 5 years ago now. So it's a real treat to be able to talk to you about AIM today.
Yeah, absolutely. I'm thrilled as well. By the way, I wasn't even in Armenia myself at the time.
You were in Ireland, right?
Yeah. So it's been a long time ago.
It's been a long time, man. Gevorg, let's start with a little bit of your background. How'd you get into computer science?
Yeah, so I'm born and raised in Armenia. Very traditional, like Armenian family. So I'd say a formative thing for me was basically my parents pushing me to go to FISMAT, which is a school local in Yerevan. So it's like a Soviet style. They jam a lot of physics and math into you unapologetically for a few years. Pretty much after that, it's either physics or computer science or math or something between those lines. So I studied in the applied math faculty of the Yerevan State in Yerevan. And then after that, I kind of tried a few universities. So it's been a mix and match. I did American University of Armenia, then went off to a startup in Ireland. Before that, I was working in Armenia. Yeah. So it's been a kind of convoluted one.
Yeah.
But I'd say those two universities have been pretty formative for me.
I think if you look back on all our guests, most of them who are entrepreneurs, investors and stuff, one of the common threads amongst them is that they're FISMath grads. You're probably like the 15th one we've had on the show so far.
Oh, wow.
What do you think is so good about the school that filters out really high quality grads, high quality scientists and mathematicians and engineers?
I think first of all, focus, right? That the school is aggressively focused on physics and math, which is, ingrained in the name of the school as well. For me, it was this exposure to a different way of thinking, competition, intellectual competition in a way that when you express yourself, the teacher, the way they engage you. So obviously, as someone like me who have had like several teachers who have been very influential, especially the formative years. Pretty much all of my friends have a teacher or two from FISMAT who have been very formative. And also what's interesting about FISMAT, and I don't think everybody talks about this, but they have took one of the key schools in the country and built it in one of the nastiest neighborhoods in the country. So that's another thing.
Why is that important?
Well, you get exposed to both worlds.
Okay. Yeah, it's like a bubble within a.
There is it takes certain level of gut and stamina to get from the gates of the school to the point when you take a bus
back home. Yeah.
That in between definitely has some adventures in it.
Okay, so you were working at a startup in Ireland as an engineer, and then at some point you decided to start your company AIM. Tell us that story.
So I was studying at the American University. I was working at one of the local companies here as a software engineer. So I started working very early on, which is not a good thing. I wouldn't recommend the kids doing that. But
why is that?
It's better to focus on studies, right?
Yeah.
But you end up doing. I had my reasons because I wanted to help my parents, etc. So I ended up landing this kind of contract gig where I was coding from a cafeteria from the American University of Armenia for this Irish company with a few guys here. Then I ended up at some point I was working with them alone, basically coding in between the exams. And then it was basically March of 2014. I see, there's a very famous Cisco exec has left Cisco and is starting a new company. And I was reading the names. I was like, these are the guys I work with. Interesting. So I had no idea. So Barry O'Sullivan was one of the senior VPs of Cisco at the time. It's a large telecommunications company. So he had left Cisco to start this company called Alto Cloud, which was partly in Ireland, partly in Palo Alto. So it was a no-brainer. I literally left. So I was already fully consumed by Paul Graham articles. I was deep into it. I was very deep into it. So it was a no-brainer.
So you knew you wanted to build a company even?
Oh, big time. When you read that startup equals growth article like 5 times, 10 times, start thinking a lot about it.
Right. Was AIM your first crack at starting a company?
Yeah.
So this is your first one, and it's so far so good.
First one, yeah. Time will show.
Right.
So I've been thinking about this for since 2017, but Gore and I, we started in 2019.
Mm-hmm. So tell us a little bit about what it is that AIM does.
So AIM is an open source library that is really good at collecting large quantities of machine learning metadata about machine learning training and other parts of the machine learning process. A lot of this multidimensional metadata, and it allows the researchers to compare them in a very few clicks in a very scalable fashion. And that's what we are known for. That's what a lot of people are using our product for.
For our listeners who aren't familiar with machine learning, explain what machine learning metadata looks like. What is it that you guys are tracking?
Yeah, right. So if you think about the regular software, the way it gets changed, humans change it, right? So when you read the code, the code is the source of truth for regular software. You can read, you can think about it, you can comprehend about it, and you can change it. And when you change, that's how basically software gets developed, and then it goes to production, and then it changes. So basically, regular software, also known as software 1.0, get changed in a human pace.
At the code level.
Yeah, and the source of truth for that type of software is the code, where that's what gets deployed. That's what the end result is. That's what you hire people to do, etc. But when it comes to the machine learning or AI, code is just the beginning of the whole game. You write the code, you need to have the data, and your goal to produce a kind of a model so that you can end up, deploying it into some type of a environment where you can bring value, right? So the way you end up building the model, the model it's a computational process where a code gets combined with data, with the compute, with some pipeline, and then the model changes at a very exponentially faster speed than software 1.0. It does change, and so the model, you cannot read the model. There is no way you can look at the model and tell it what it's going to do, how it's going to behave. It's a stochastic process most of the time, or all of the time. And then basically you cannot interact with it directly, so you need to interact with it, look around and so that's where metadata comes in. Basically everything you track about the model while it's training, before, all this information, that including the code. This is maybe an unpopular opinion. As far as I'm concerned, code is also machine learning metadata.
What do you mean by that?
It's part of the puzzle that makes the model happen. Maybe data would be a stretch to call a metadata, but code, for instance, includes the hyperparameter, right? So you kind of say, oh, these are hyperparameters. I want to tweak one value inside the hyperparameter and then rerun again. And it's the same with code. If you tweak even a small, dropout whatever value, or maybe a small tweak in the architecture, or maybe size of the feature vector, that's still, you want to try to get a model.
And AIM tracks all of that.
Oh yeah, we do track everything that moves.
So you guys kind of do version control for machine learning?
Yeah. Whatever we track, it definitely gets version controlled. Right. But it's not just version control. We track large quantities of multidimensional metadata. And so by saying multidimensional, I mean, imagine one machine learning training can have several hundred hyperparameters. Several hundred metrics. Each metric can have up to a few million steps. By saying step, I mean metric is a sequence of numbers. Each number is a step, right? Mm-hmm. And then this is just the metrics. What if you decide to track some intermediate images? Mm-hmm. But for instance, you run 64 epochs, and then you take a batch of 64 images and then run 5 times each epoch. Then multiply the numbers. That's that would be a very lightweight way of tracking images during training. So there's a lot of things that move during the machine learning training. And our library tracks a good number of that stuff.
Right, yeah. Earlier you were speaking about software 1.0 and 2.0. Machine learning fundamentally is very experimental. It's more scientific, you could say, although it's still, I think, an engineering discipline. So there's a lot of things that are tracked at pre-production stage, the development cycle, and even when you push it into post-production or into a production environment. So there's this whole tooling that is being built in order to help bring machine learning models out of the labs and the universities into the real world in production. And this is what we call MLOps, right? So there's DevOps that emerged 20, 25 years ago with tooling like AWS and Docker and Kubernetes and stuff. And now there's this sub-industry emerging around MLOps. Tell us how you sort of see that space today, how you see the tooling being developed and maturing.
Oh, man. Well, there's several versions of this conversation we can have. So it's obviously one of the fastest growing and hottest areas of this whole machine learning frenzy, which is a real one. The real companies are being built with real revenues all across the pipeline. So tooling is essential, right? So first of all, it's important to state that for the type of work that you do with machine learning, you need to have tools to be somewhat efficient. Therefore, the need for these many companies are emerging at different parts of this infrastructure that are trying to solve pains.
Yeah.
And so it's quite competitive. There is lots of players out there, basically targeting many different actors in the market: the researchers, the MLOps people, the labelers. Mm-hmm. So there's quite a bit of people involved, right? Because first of all, you need to have the data, then you need to have the compute. So there's layers. You need to somehow organize your work. For instance, say, first run this data labeling job, and then run this training, and then run XYZ. So that's kind of horizontal. And then you build like layers and layers of other stuff, such as track this metadata, then do eval or do something else. So and then you could see companies are evolving to fill in
those gaps.
To try to answer those, because but in my view, a lot of it is still quite fragmented. These tools are quite siloed. They are somewhat integrated, but not in an extent that there is no clear mainstream ones, maybe besides the Hugging Face transformers, which is do I need to explain what Hugging Face transformers is?
Probably, yeah.
Yeah. It's an open source library that basically provides a framework of a base model, which is called a transformer. It is a language model. You can use it to translate. You can use it to say name entity recognition. Name entity recognition when you have a sentence and you want the machine to say, there was Donald Trump in the sentence. That's named entity. Mm-hmm. This is one of hundreds of these applications that these transformers are really good at. And this is kind of can we say it's the one of the early foundation models before GPT? That's totally, kind of fair to say,
2017,
right? Yeah. They build these models, and then so that people can come in and fine tune. It's called fine tuning, where you say, you build this base model where I can have for instance, I have my own data. Say you are a call center, right? When you're say you're a call center company, where you have lots of customer chats, you want to say, let's train a bot so that talks with our users or like customers, and then you can say, take this transformer and use this existing data that we already have, and train a new model from it, and then use it for our that's what Hugging Face is. So they're like pretty mainstream because they were able to convince the people to come around and build around those models.
And give people access to those foundational models really early on.
Yeah, it's also open source, so it's easy to easy to distribute and use and contribute. And
Do you anticipate kind of a consolidation around MLOps tooling as the ecosystem continues to mature? Because right now there's a ton of players really competing for a few narrow spaces, right? Like there's people competing for the annotation market. There's people competing for experiment tracking, people competing for model performance monitoring, etc. How do you see it evolving over the next, let's say, 10 years? Because in the traditional DevOps space, really a couple of big players monopolize the whole thing, right?
Mm-hmm. If you look at the story of the traditional DevOps, or just overall the story of these types of developer tools, or story of these types of fragmented markets, usually what happens is somebody orthogonal comes in. Can we say orthogonal? So orthogonal means you're playing on this, playing field, and then another playing field gets created.
Right.
That's you're like not aware of, or you didn't anticipate.
Yeah.
Basically a kind of a completely new way of doing things that comes in and makes the other guys obsolete.
Mm-hmm.
So I see a consolidation happening in that fashion, as opposed to somebody becoming so big that needs to be new ideas.
You mentioned earlier foundation models. So foundation models are these large machine learning models that are built by the big players like Google, OpenAI, and stuff. And then through Hugging Face, or sometimes by the companies themselves, they release it through an API, or maybe they open source it, and people have access to using it. How does the transition towards foundation models, these large models that the average team or company isn't going to train themselves from scratch, how does that impact the MLOps space? How does the tooling begin to differ in the way it's applied and used?
So obviously one of the challenges for foundation models is the deployment, where you need to
Right.
make it like low latency, all that stuff. So the way I see, the companies are still going to somewhat iterate over those models, even if it's available via an API. So there's going to be basically a kind of clusters of different companies that do different things with them, right? For instance, if you're I don't know, they're nowadays they're like real companies using, say, OpenAI, APIs, or
Hugging Face.
stable diffusion model, model, etc., or Hugging Face, models that are generating real revenue, and they are kind of building on top of those models, but they are not doing the pre-training part, which is very resource intensive, but they may be using an API to fine tune, or so there's like several different ways of thinking about this. As far as we are concerned, the models never stop being stochastic, and the metadata around the models always need to be collected, because you need to still connect the dots between what did you try and how did it behave, etc., etc. But definitely some companies are going to, transform. So there is a lot of it kind of depends on the layer these companies operate on, because when we speak about the MLOps space, we kind of need to talk about where do they operate. For instance, would the pipeline companies change what they do? Maybe not, right? Because they don't really deal with the compute themselves. They just say, oh, let me organize this work and give you a dashboard to organize it. And then the other question is, oh, great, foundation models are great, but in reality, there is a bunch of other predictive models of different types that are still out there being deployed, bringing value to companies, and companies are building around them, etc. For instance, maybe you shouldn't try to kill a fly with a big gun, right?
Right.
So therefore, foundation models are going to definitely enable several categories, revolutionize the way some of the companies think about themselves, what they do and how they do. If you're any kind of company who does with the image editing, you should be deeply thinking about it. If you're any kind of company who does something with text, chatbot, or search even, right? So you can open that conversation with a search. So basically, these foundation models at this stage are really good at a few things, right? They help you write code, right? The Copilot. They help you do a lot of stuff with text, and they help you do a lot of stuff with images. But not every problem is out there in the scope of those types of generative
tasks,
style problems. There's still a lot of other machine learning models are bringing value to different companies, and while there is a chance that these models can come in and completely take over all these other areas, it will take a little bit of time, and then depending on where you are on the layer of infrastructure, that may or may not affect you. For instance, if you're a compute level tool, say, I don't know if so Slarm is a PyTorch. Slarm is a tool that allows the engineers to organize a multi-GPU training of machine learning models. So, or for instance, Ray, it's a company on top of Ray called Anyscale. OpenAI uses Ray to train those models.
Right.
So, therefore, there is also the other group of companies who do train those models. And a lot of the competition with them is about the scale and not the scale, about the compute and understand how big of a compute can you have and how much of stuff you can train. They do need tooling, right? As far as I'm concerned, that doesn't aggressively affect the MLOps space in a way that it may be thought about. But definitely there is some tweaks different companies are going to need to do to be able to adjust.
Yeah. Foundational models might just create a lot more opportunities for companies that traditionally wouldn't have implemented AI in their products at all to start integrating them, rather than sort of just wipe out all the companies that were training models from scratch, or just training models, period, I think.
Yeah. So there are companies who train all sorts of models, or try to build all sorts of infrastructure and trying to get lots of value, all sorts of value from them. And examples like in industrial cases, examples are in like a lot of tabular data is out there still being auto ML'd into different prediction models, right?
Yeah.
So it's not really straightforward. One way to look at it is to look at the way people are going to apply this. Foundation models are definitely going to create some, even maybe industries or even enable like categories, etc. But saying it will disrupt everything that comes around, maybe in a 10-year time, yes. But in the short term, there's still like lots of activity all over across the board. Because, for instance, not too difficult to find companies who deploy very simple models like logistic regression, because they care about the explainability, right?
Right.
And they have a kind of, or decision trees. They care about the explainability.
Yeah.
I don't think it's very difficult to find people who extract value from those models too.
I have no idea what the percentage is, but traditional ML models are definitely still something that get deployed in products. So let's get back to AIM. Tell us a little bit about what type of organizations are using your product.
Yeah, so recently it's been quite a bit of growth of different companies. We have like issues being opened by the Amazon ML, Facebook AI Research. So that's kind of the larger end of the companies, and obviously smaller startups as well, and everything in between. So AIM has recently become a top 1% of all Python libraries ever.
Wow.
So it's like
on GitHub?
On PyPy.
On PyPy, right, sorry.
Yeah.
That's
so
incredible.
It's heavily downloaded.
Wow.
It's heavily downloaded. We see a lot of people are using AIM to run humongous amount of training runs. That's what it's especially good at. And, we work with a few groups who have been like comparing tools together, and so according to those comparisons, we may be world's best experiment tracking, open source experiment tracking, maybe.
1% of all Python libraries downloaded. That's really
crazy,
really amazing. Yeah. Again, I'm just thinking back to when I first heard about this from you in like 4 or 5 years ago. So that was really, really cool. I'm happy for you. So you guys made a conscious decision to build the tooling open source. One, why did you guys decide to do that? And secondly, do you credit that for a lot of these big organizations like Facebook AI and Mila and stuff using it? Like, does that give you a level of visibility and exposure that helps large players adopt your product?
Honestly, the decision to go open source was a little bit more pragmatic / conclusive. So basically, my co-founder Gore and I were like thinking about the product. So my background is I have been building machine learning infrastructure since like 2017, and I had a chance to be exposed to a lot of the problems even today that are kind of some categories are kind of being spun up. So it was pretty much obvious at the time that all of these need to exist for somebody like me to not have that much pain. Because I did have a lot of pain, like at the time of trying to figure out, for instance, how do I make several hundred models work at the same time, and then how do I keep track of all of these, moving pieces, right? And obviously we had an idea of what had to be built. So we have decided, let's go and talk with a lot of researchers and like make a product for the researchers. And we decided, let's make it enterprise, closed source, etc. As us being, a faithful believers of what Paul Graham has to preach about talk to your users and customers and build, talk to your users and customers and build. Let's go. So we started with that. And some of the problems we were having was we would get like having a pilot with a company XYZ, and then this company XYZ says, if you build this specific feature, that would be great. We would need that. That would add us a lot of value. Okay, great. We go back. We take 2 weeks. We build it out. We go back, say, hey, we already built it. Great. We're deploying. We're doing it right. Then say, I'm already out of that problem right now, and I have this problem right now. There you go. And then we go back and build. So we found ourselves in this endless cycle of catching up with these moving requirements, right? And so that's what led us to believe, maybe we should think about the foundation. We build in a certain roadmap, and people, if they want extra stuff, they can build for themselves. But also, it would be so much easier to try out our work. Right? Because it's low barriers. And then also we would get in those conversations a lot easier and faster.
Yeah.
And also we obviously the DNA of the machine learning is in the open source, if you think about it. The DNA of the infrastructure is in the open source.
PyTorch,
all of the tools we use are open source.
Yeah.
And so it was basically this compound decision that we made. There was also another component to it of, okay, great, suppose you go to open source. Where do you start from, right? Actually, let me go back. So 2 other things that had happened that made us deeply, go towards open source. So the conversation with Ian. So Ian is, so there's this company called Mattermost that is building an open source Slack. Have you ever heard of Slack?
No. Slack, yes.
Yeah,
not
so
the open source Slack.
They're a very successful company. So it was why would you build an open source Slack, right? The question, because Slack already exists. Apparently, they have quite a number of customers, etc. A few conversations with him really opened our mind. So at the time we were at the Berkeley Skydeck, we got introduced by a few, introductions, and so we were lucky to have that chat with Ian. And so that has been basically a turning point for us. It was it's possible to build a great business on top of open source.
Right.
And was let's go.
For some people that might not be so intuitive, can you talk a little bit about how an open source product turns into a business? How do you guys monetize it? How does that work?
So the recipe, I'd say for open source is very much similar to what freemium is, right? You build a free product and hope a lot of people will use it, and then you hope either an extended version of that product or maybe even something parallel to that product that's somehow connected to each other with basically 2 ways, right? You either sell an extended version, which is the freemium, or you use an open source project to as a channel to lead to another product that's a paid product.
Right.
So those 2. And then basically the name of the game is, can you make your open source project so useful and so famous and so kind of mainstream that many people will use it, and then then that would allow you to build a business. But then obviously there's the risks where what if your commercial product is a competitor of your
open source?
That's the biggest risk. So first risk is making it famous. Second risk is too famous.
Is it more of a risk that the open source version becomes a competitor of commercial version, or is it the commercial version that
you need to define those lines? And that's a very tricky one.
Right.
And the most famous example is obviously the Docker,
right?
Because they made one of the most heavily used infrastructure tools out there, and I'm not sure if they were able to fulfill the commercial side of it.
Right.
But it's it's everywhere.
It's a balancing act.
Yeah.
So you guys have a commercial version of AIM as well?
We are in the process of building one.
Got it. Yeah. Okay. And any advice for people looking to build on open source?
One of the key advice to basically anyone building anything, but especially open source, is to clearly decide between yourselves what's your focus. Because once you are out there in the wild, you get pulled in all sorts of directions. Yeah. You have to have a clear idea what you're trying to do and stick to it, because it's so easy to build inches deep, miles wide.
Yeah.
But what you want to do is to build miles deep, inches wide. That would be my main advice.
Well said. Gevorg, last question. What do you hope to see for the future of AIM in 5 to 10 years?
So in the next 5 to 10 years, we want to help as many researchers as possible to build the models, faster and bigger, and really, help this wider AI community to transform basically the world with these new capabilities that AI brings us, to basically unlock a new type of productivity. Our mission is to basically build this democratized tooling that would allow many people to do it as fast as
iterate as fast.
Yeah. Basically, what we really care about with this is to enable AI researchers to have a very high velocity of iteration with building this, basically taking those models to production. That's what drives us.
Right.
How fast can you iterate on this? And and I feel like a lot of the dev tools should maybe think that way, but yeah, that's our goal in the next 5 to 10 years. Unlock a lot of these productivities that AI is going to bring with it.
Right.
Faster and better.
I wish you a lot of luck with that, Gevorg. It's awesome to see AIM's success over the last few years, and looking forward to seeing more in the future. Thank you so much for being here today.
Thanks, appreciate it. It was awesome to chat.
Thanks, Gevorg.